Welcome to the Mr. Smart Maths channel, and my name is Mr. Smart. In this video, we're going to be looking at prime factorization, and that is the process by which a number gets split up into a set of prime numbers that multiply to make that number up. Okay, let's look at an example. We've got a set of numbers on the right hand side. These are the first 8 prime numbers. And the question you should ask yourself is, when you get given a number to split into its prime factors, is there a prime number that I can divide that number by? So in the first example here, we've got 24, and because 24 is even, I know it can be divided by 2. So that's why the 2 is written on the left-hand side. And I know that 24 divided by 2 equals 12. Now you'll notice that 2 has been circled, and that's because you should circle the prime numbers. So I've circled 2, and there's a good reason for that, which I'll go into at the end. Okay, 12 isn't a prime number because it's not on the list on the right, so we can split that up further. So again, we look for a number on the right-hand side that can divide into 12. I'm going to choose number 3 this time, and circle it because it's a prime number. 12 divided by 3 is 4, and then finally 4 can be divided by 2, which is prime. And 4 divided by 2 is 2, which is also prime. And that's the way that you know when to stop this process. When you reach, if you like, one of the branches in your tree and both those branches are prime numbers, that's when you know when to stop, because you can't break down the number anymore. So what numbers do we have here? We've got 3 2s and a 3, which means that 24 can be written as 2 times 2 times 2 times 3. Or 2 cubed multiplied by 3. Okay, let's check out the number 66. 66 is in the 11 times table, and 11 is on that list of prime numbers. So 66 can be split up into 11 multiplied by 6. 11 has been circled, 6 hasn't because it's not a prime number, but 6 can be split up into 2 multiplied by 3, and both of those numbers are prime. So we know now we can stop. And what numbers do we have? We have 2, 3 and 11. And so 66 is 2 multiplied by 3 multiplied by 11. Okay, let's have a look at a couple more examples here then. Because actually, you don't always need to find a prime number that divides into the number that you're looking at. So 2 examples here of that. 72, I just happen to know that 72 very quickly is 8 times 9. Okay, I know it divides into 2, I know it divides into 3 and some other numbers, but knowing my times tables, I know that it's 8 multiplied by 9. I've not circled either number, but what I've done is I've basically split this into 2 separate questions. So the 8 can be written as 2 multiplied by 4, and the 4 can be written as 2 multiplied by 2. For the 9, I know that that's 3 multiplied by 3, and both numbers are prime. So we stop at that point. How many 2s did I write? I wrote 3, so 2 times 2 times 2. How many 3s? There are 2 of them, 3 multiplied by 3. And so 72 can be written as 2 cubed multiplied by 3 squared. Final example, I've got 560. When you've got big numbers, look for easier numbers that can break that number down. So 560 I can split up into 56 multiplied by 10. And 10 I know is 2 multiplied by 5, which is good because both of those are in the prime number list, so I can stop there. 56 I know is 8 multiplied by 7, so I'm going to write 8 and 7. 7's in the list, so we're going to circle it. And then the 8 from the previous question is 2 times 4, and then the 4 is 2 times 2. So that's when I know when to stop. How many numbers have I written? I've written 4 2s. So 2 times 2 times 2 times 2. And there's also a 5 and a 7, meaning 560 can be written as 2 to the power 4 multiplied by 5 multiplied by 7. Be sure to check out the Mr. Smart Maths channel on YouTube, and don't forget the website mrsmartmaths.com. See you again soon.